Question number 21. This question is about two salts, sodium iodide and sodium chloride. The two solid salts are separately added to warm concentrated H2SO4. The results are noted. Aqueous solutions of the two salts are separately added to silver nitrate, and then concentrated ammonia is added and the results noted. Okay, so the first thing is when sodium chloride reacts with H2SO4 and the products form, when they react with ammonia, they will give white PPT. So answer cannot be A. And same thing for the presence of iodide ion, it will give yellow PPT. So answer would definitely be between B and C. Now we have to see the amount of products that the products they will form. So sodium chloride, when it reacts with H2SO4, only produces HCl, and when sodium iodide reacts, this again we are talking about theoretical things, reacts with H2SO4, it produces I2. So sodium chloride does not produce Cl2, so sodium iodide produces I2, it produces sulfur or sulfur dioxide, and finally H2S. So as you can see, answer should be C. And because sodium chloride does not produce, and this is mainly because down group 7 reducing power increases. That means the elements lower down the group 7 are stronger reducing agents. Okay, the diagrams show the process of adding calcium nitrate and strontium nitrate to separate boiling tubes and heating them. Identical conditions are used: calcium nitrate, strontium nitrate. As the reactions proceed, the water containing universal indicator changes color. Which row shows the color change and identify the nitrate that causes the... Okay, first let's see which nitrate will cause the quickest color change. So down the group 2, thermal stability of nitrate increases. So SR, strontium nitrate, more stable than calcium nitrate. So calcium nitrate gives quicker change in color. So answer will definitely be something between A and C. The next thing is when when the nitrates are heated, they form the oxide, plus they form nitrogen dioxide gas, and they form O2. Similar for strontium nitrate as well. And we have to see the color change. Now we have to know one thing. You have to know the basic color change in the universal indicator. That is, as conditions get more acidic, color of universal indicator gets more darker and becomes red. So it becomes red, right? So by that, this is something you need to know. The color changes and so the answer should be C. Question number 23. The equations for 3 reactions involving chlorine or its compounds are listed. We can see the reactions. Which statement of all these equations is correct? So actually we will have to go by trial and error for each option. Equation 1 describes the formation of a compound used to kill bacteria in drinking water. Not really, because the compound that is needed is the ClO minus. So this is the compound that kills bacteria, and I cannot see that in equation 1, so A is wrong. Equation 1 does not represent a redox reaction. What I can see over here is that it does represent a redox reaction. because there is like, so oxygen here is 0, right? Potassium here is +1 and chlorine is -1. Here potassium is +7, right? Oxygen is -6 and this is -1. So I can see that oxygen, the oxidation state of oxygen atom has increased, right, by +6 from -6 to 0, and the oxidation state of potassium has decreased from +7 to +1, which is reduction, and this is oxidation. So that is why I would say this is wrong as well. Equation 2 describes the formation of potassium chlorate IV. Equation 2 describes the formation of potassium chlorate IV. So here the oxidation state of potassium should be 4, but I cannot see it to be 4, it's rather +7, so this is also wrong. Equations 2 and so this should be your answer. Let's check. Equations 2 and 3 both present disproportionation reactions. Okay, let's see here. Potassium is +7 and oh sorry, this is +9 here, sorry, mistake. So +9 over here, so it is increasing, and again here it is decreasing. So this is a disproportionation reaction where one species both reduce and oxidize. So the 2 is correct. For 3 here I can see that it is +1 over here, and it's +1 over here, it's 0 over here, and here it is again +1, here it is +7. So oh sorry, this is +3 because hydrogen is 1, oxygen is so yeah, it's +3 over here, so it is decreasing. And also 1 minute, -1 CO is +7 +6 +5, not 1 minute. Here potassium is +1, so that is not representing any sort of disproportionation reaction. So here it is 0 chlorine, and here chlorine is -1, and here chlorine is +6, so it is +5. So I can see that chlorine in this equation has either reduced or oxidized. So here answer should be D. So for this one it was about chlorine, and this one it was about potassium. So okay, question 24. Nitrogen monoxide is a primary pollutant produced by petrol engines and is found in their exhaust gases. So we know that the nitrogen oxides and the carbon monoxide is converted to nitrogen and carbon dioxide. So we'll see which equation. So it's NO plus CO, not NO2, wrong. NO plus CO2, NO2 plus CO, wrong. NO plus CO, N2 plus CO, this could be the answer. NO plus CO, it's carbon dioxide is one of the products, it's not converted, it's rather one of the products. Question number 25. The diagram shows the structure of naturally occurring molecule cholesterol. So this is cholesterol. Shown next here, the 17 carbon atoms in the 4 rings all lie in the same plane, means they're planar structure. But why this is wrong, it is because I can see this to be tetrahedral. I can also I can see this to be tetrahedral. This is 109.5 degree, which is not planar. This is not planar, so X is wrong. Student Y stated that this molecule displays cis-trans isomerism at the carbon-carbon double bond. So for this, this is wrong. Why? Let me say. So the carbon atoms in the structure are arranged in a ring, so they can't switch or change position. So they're fixed in their positions. Even though there are double bonds, they cannot rearrange themselves for cis trans, as I've told, because in ring structure, remember this theory, this is one theory you might need more than this question, that in ring structure carbon atoms cannot move. So both are wrong, so I would go with answer B. So now we'll see question 26. The drug cortisone as the formula shown, cortisone. In addition to those chiral centers marked by an asterisk, how many other chiral centers are present in the cortisone molecule? So I can see 1 to be there, because so chiral centers are the ones with atom, so carbon atom with 4 other different atoms. So I can see 1 carbon atom there. They have told that the ones without the asterisk one we have to consider. I can see 1 to be there, 1 to be there. So also remember that atoms with double bonds are not considered chiral centers. So for that reason, this cannot be a chiral center. So it for the formation of chiral centers, it has to be only 4 different atom groups or groups of atoms, and they all have to be single bonds. So for that reason, I can only see 3, and okay, so the maximum answer is 3 anyways. So even if there are, we cannot say it. There are not. Okay. Butane reacts with cold dilute acidified KMNO4 to give product X. Butane reacts with hot concentrated acidified KMNO4. So one is cold, one is hot to give product Y. We'll come to the conclusions later. Okay, so the options are mainly about the 2,4 DNPH. So let's see. So butane, when it reacts with the cold dilute acidified KMNO4, 2 OH groups will be attached on the area where there is the double bond. So one will be here, one will be here. So that is what I've just shown, and the double bond will break. So now here we do not, for the 2.4 DNPH test, there has to be CO bond, and that is like mainly for what do we say, aldehydes and ketones. So that is not present here, and so that is one thing. And for the hot one, for hot KMNO4, the product Y is, it will be that for the hot one we have to see the groups around the double bond. So there is one R group around each of the carbon atoms, this carbon atoms, and one H group. So whenever there is a structure like this, we form acids. So there will be 2 CH3 COOH that will form. This one also does not have the CO group. So the NPH is for the, oh sorry, actually 1 minute. So it is 2.40 in pH, gives an orange PBT. For R, I am denoting R for the alkyl or methyl groups, so RCOR or maybe RCHO, that is the ketones and aldehydes. I cannot see a ketone or an aldehyde in either of these two compounds that will form, so it should be neither product X will react or nor product Y will react. Answer should be B, as they have asked, which is correct. Question 20. The sequence of reactions take place. The major product is compound Z. So the major product. So we'll first draw propanoic acid, or this propanoic acid. When this is reduced by LiAlH4, when it is reduced, it forms propanol, right? And again, when this reacts with H2SO4, it will form an alkene. This is the alkene that will form, but I'm not showing the hydrogens. You people know that there will be hydrogens. And to get the major product, which is compound Z, we have to attach the the functional group of OH as steam is passed. So this is a hydration reaction, so it will be attached to the carbon atom with more alkyl groups. In this case, this carbon atom is the second carbon atom because it has one alkyl group, but this one does not have no alkyl groups. It has no alkyl groups, so the product should hence be this one, right? This should be your ideal product. So this is the major product, and this one is propan-2-ol or prop-2-ol, and so answer should be your D. Question 29. Which statement is correct? Bromethane reacts with NaOH to form ethane as a major product. So here, not really. Ethene is not the major product. So bromoethane reacts with aqueous NaOH, so alcohol forms, and a sodium halide will form, NaX, and so there is no major product of ethene forming. For part B, one chlorobutane reacts more rapidly than one bromobutane with NaOH at the same temperature. Not really, it's rather the opposite. CBr reacts more rapidly as CCl is more stable, so B is wrong. Hydrolysis of C2H5,3Cy mostly occurs by the SN2 mechanism, so for it to be SN2 mechanism, it has to be a 1 degree structure, and for it to be an SN1 mechanism, it has to be a 3 degree structure. Now for it to be SN2, the structure has to be a 1 degree structure, and this is not a 1 degree because there are three alkyl groups around the CBr bond, so that is wrong as well. So it should be answer D, but let's check. See, the CH3CH2CH2CH2 plus ion is less stable than the CH3C plus, so 3 degree is more stable than a 1 degree, and this is a 1 degree ion, and this is a 3 degree. By 3 degree I mean the tertiary structure, and this is the primary structure. So this, because this has 3 alkyl groups, right? 3 alkyl groups, so less stable. That is a perfect statement. So we will move on to question 30. In the hydrolysis of bromethane by aqueous NaOH, what is the nature of the attacking group and the leaving group? So attacking group is the bromide ion and the leaving group is OH minus, and both of them, both Br minus and OH minus, are nucleophiles. This is again from the theoretical knowledge, and answer should hence be D.